Good day, viewer. Here I'm demonstrating my physics projects in which we had to create two different, we're using verlet integration, create two different soft-bodied objects and have them kind of interact with each other. The two objects I chose to make, one is a blob which you can control, and the other is a platform suspended by ropes. Though the ropes are invisible, they are there. Jumping right into the demo here is the best way to show it off. So the blob and the platform are both, of course, verlet-integrated objects. I just made the platform's constraints a lot stiffer than the blobs. And it really jiggles around. You can really see the vertices showing, but it looks pretty good otherwise. It kind of clips into the platform sometimes, but stays pretty much, I'd say, completely on the platform as the platform sways. And of course, you can inhabit it here. I can jump, can move on, air quotations, jump. I can move around with WASD. It just grabs the, say I want to move in that forward direction, it'll just grab the points furthest on this side and then a few of its neighbors and just kind of pull them in that direction or set their position in that direction, and it pulls the whole thing. It works pretty nicely. Also implemented some like friction. Okay, it does flatten out here, that's fine. Just jump and you can reinflate them. But implemented some kind of friction, so if I move and I stop moving, it starts to tumble along like a blob would if it moved, which looks pretty cool. You can see the platform there. You can back up here. It can jump as long as it's touching an object, so such as the platform. So you can kind of, it's a little difficult, but you can skate along the edge here and eventually pull yourself up. Hopefully. Well, whatever. It's not necessary. I can always relaunch it. But jumping right into the code, I'll go over how I detected collision between this blob and the platform here. Let me go to my update right here. And the applied collision was the worst part. So the verlet update just adds downward velocity to it. It's innate acceleration. And all that verlet fun stuff. Satisfy constraints, just make sure, yeah, all those constraints, it just applies, updates to them. It's pretty straightforward. I'm not terribly descriptive, but applied collision is where the real meat is. There's my meh friction. So this part's just for checking if it's at below y0, which is just like the infinite plane that is the floor. But the platform is different. There's two scenarios where I will detect collision. One is where a particle's old position and new position go past a triangle's face. So of course that platform is made up of I believe like 12 triangles, and I do detections on all the triangles for each of the particles. It's a little intensive, but for a small demo like this, it runs pretty okay. So detected particles go past that plane, and if it is found to go past the plane, it gets where it goes past the plane, so I can have the u, v, and the barycentric coordinates of the triangle, so I can apply a proper force distributed among the three vertices of that triangle. And then I just set the particle's position to like just some really small value right off of the face. And then what do? I take off I normalize its movement vector on the normal of the triangle, and I delete that from its overall movement. So instead of like going through the platform, it'll pretty much stop at the platform and then move along the plane of that platform, however much longer it would have gone. So it still slides along rather than making it like sticky to the platform. So that was the easier way to detect collision. The harder one was when the platform passed by the old and the new positions of the particles, because the platform, of course, moves by itself. So in this part, I do checks for if the old particles and the new particles are on like different different sides of the plane created by the triangle. Based on the new and old positions of the triangle itself. So for like the old position of the particle, I check the old position of the triangle and the new position of the triangle and see if it's on the same side of both those triangles, then it's fine, there's no collision. If it's on opposite sides, I can tell that the triangle passed by the particle and I can take relevant measures. Measures aren't very proper. I thought this all up myself because I think it's kind of fun to kind of string together your own solutions, though they're probably not the most effective. They look pretty okay. You saw that slime kind of swaying on the platform there. I'll pull it back up. But yeah, those are the two big collision possibilities. Two big possibilities for collision. Yeah, I'm gonna get the blob back up here. It's nice. It's fun to just kind of watch it sway back and forth as the platform jiggles. I don't think overall force gets gets released properly, so this platform will always be jiggling a little more. But yeah, that's about it here. The ropes I have aren't directly above these vertices. They're like above and a bit back that way. So all the ropes kind of slope in, gives it a little bit more of a sway to it when you put pressure on one side. But yeah, that's about it for this video. Thanks for watching.